Hey, hi all. This is Prudhvi. I work as a data scientist at Graminer, a data science company. I usually work with LLMs, means I try to incorporate LLMs wherever it is needed or wherever it's not needed. Then I'll realize, okay, this is not needed here, and wanted to share some experiences with you guys such that you can incorporate all the LLMs that you use. I believe all of you are using LLMs daily basis, right? So wanted to share some experiences such that you can also use LLMs in your daily life, which will make your life easier. So it's not replacing humans, but they are with you, along with you, to fasten your process. So you can do your job in one day instead of 3 days, right? So I'll come to the point why we need LLMs in data engineering. Now I am focusing on one particular topic here, which is data engineering, because somewhere in the working days I felt that the engineering team is being doing the data pipelines, ETL pipelines, ingestion pipelines, or quality pipelines. We can actually automate this and we can actually accelerate this before without doing it manually every time, right? So we see that modern data systems are large and constantly evolving. We see that models are being released very frequently. We see that models are very fast and accurate, and why don't we use that in our enterprise level itself, right? With some guardrails, what we have to introduce, but we'll see that. So if you come to data engineering pipeline, so there will be a lot of pipelines, right? The quality pipelines, ingestion pipelines, the ETL pipelines, which is extract, transform, and load, where you'll transform a database to one to other, which usually takes a lot of time and usually have to maintain a bit. Now, if something is break in between or something is broken in between, if there is a change in schema or if there is a change in the data, if a value becomes nullable, because the data keeps updating, it's not constant. So if a value becomes nullable, the pipelines which were already built will not break instantly. It will break after a time or after a particular time period. Now when it breaks, we have to come debugging, and then okay, later we realize that this is where it broke. Instead, what we can do, we can automate few things on pipeline itself, where we can reduce the manual effort and we can actually automate and accelerate the things we do. So usually in data engineering, in building the pipelines, the human, which is us, the employees, spend times for writing schemas. Schemas are basically the data types of your data set. So you have a data set, you have a SQL database, you have a DB or whatever it is. We will write a schema for it. Schema tells what column type is what of type and which data type it is. So we write schemas, we write DBT tests. DBT is a data build tool. It's a Python framework where it used to check the quality of your data. So instead of you being a data analyst going through each and every row, we write some rules and we'll test it on the database. So we'll get an idea how quality of our data is and how good are we maintaining it. And debugging mismatches, obviously we'll spend more time on. Now, we have LLMs who are good at reasoning, good at understanding context. We don't want LLMs to come in our pipelines and guess something what's happening. Instead, Sanjit was saying that building context is more important. So we'll build context for that and then we'll use in our pipelines. So because they are good at reasoning, because they are good at understanding the context, we'll leverage that use to our pipelines. So when I say schemas are actually living artifacts, right? They are not static contracts that you write once and then you leave it and you ingest in the pipeline. They are actually they change according to the data changes. So your data keeps updating, your data is live, and then your schema is also will keep updating. So for building the context for an LLM, you don't need to give the database itself to an LLM. You don't need to pull all your database to an ChatGPT or Claude models to understand what exactly is happening. Instead, we can give schema of the dataset to an LLM. So schema comes with the column names, rows, and the data types of the columns. If you provide that context to the LLM, which LLM it is, your choice, OpenAI, Anthropic, whatever it is, and then we say, okay, do this, it will have a better context and an accurate results, we can do that. So I will show something, a live demo here, where I built something that I felt is an accelerator, and which is an accelerator. So it's called Schema Forge, where I actually send the schema of a dataset that we upload to an LLM and ask it to build three things. One, the description of the datasets, each and every row, what it's doing, each and every table, what it's doing. And two, the relationships and entity diagrams. So usually the engineering team also spends in creating the entity diagram and the joins and relationships, modelings and all. And three, at last, with all this context, I ask it to generate DBT rules with which I can check the quality of the data that I have. So yes, so it's a web-based currently that I built, but we can have this as APIs and whatever in the enterprise level code system has when we can adapt to it. So the data flow is like this. We'll take the data, we'll infer we'll pass it to the schema forge. And what it does is it infers the schema, it detects the relationships and modelings, it detects the data types, and then it generates the DBT rules, and we'll validate accordingly, right? I'll jump into the live demo. Let me pull this. So before showing the demo itself, I'll show you the database or data set that I've been using, such that you'll get a better context of what's been happening, right? So this is a database. I converted it to Excel such that I can show it clear. Okay. Is that clear? Okay, I can't see it. That's fine. So yeah, this is the data set I'll use to show the live demo. So this is how it is. It has 6 tables. Consider each sheet in the Excel as each table. It has multiple, this is a pharma trials data set where I created. So it has patients data, it has doctors ka data, it has lab results, it has adverse events related to the pharma trials, right? So this data has a lot of information with it. Now, by looking at the data as a third person, who not built the data, I don't know what PT underscore type is. And this is how typically the datasets be, or the databases be, because someone develops it, someone organizes it, they have the documentation. But as a third person looking at it without any context, I don't know what PT underscore type is. I don't know what ETH underscore FL is. I don't know what BAM score is, right? So, and even LLM doesn't know it, because we haven't passed it yet. So what we will be doing here, I'll just upload, and this has 6 tables, you can see 6 sheets, I'll just open them, which is of very similar types, right? So what I'll do now is upload this to Schema Forge, and let's see what it does. Okay. So I'll upload this. You need to configure the LLM, which I did. Okay. Apparently I didn't. Okay, let me 1 second. I'll just pass my key and give it. It's a secret. Yes. Pull there again. So yes, I configured OpenAI here. In this case, I'm using GPT 4.1 mini, which is kind of outdated, but I'm fine with it. So what it does, the immediate I upload, it takes the schema of the dataset along with some sample rows that I sent, because I want the LLM to be most accurate as possible, because I don't have any personal information or client information in this particular dataset. So I passed 10 random rows, not the head of the dataset, but 10 random rows of each sheet along with the schema of the dataset to give the LLM better context. So as good as the context is, as good are the results are. So the patients table which we saw, So it detected PT type is a string, and it says patient type code. It's a category ABC which may hospital have or may hospital have categorized. And the ETH score is a string as well, and it says ethnicity flag. So maybe it's an international hospital and they have African, Asian, and Latin American, all of this. So, and it does same for all the tables that it have. I haven't shown you the 6 tables, but this is all the 6 table. The benefit here is by giving the schema and sample rows of each table in the whole database, it also recognizes the relationships and the modelings of the dataset. So what is the primary key of this table? For example, you can see the patient ID is primary key along with the PII tag. So PII is personal identification information, where it treated as sensitive and it will not be shown everywhere. So it detects the foreign keys, it detects the primary keys, and it detects the PIIs. Now I have very good understanding, very good information about the data set that I have, right? So it generated all the schema for each table in the database, and it also gives the constraints of each columns. For example, in patient's table, in the patient ID, the basic constraints it needs to have, it should be unique because each patient ID is mapped to each patient, and it should be not null, obviously, and it should be a positive integer. So it's a foreign key references. It says clinicians.site ID, which is a clinician's table. It connected to a clinician's table with a site ID as a foreign key, and it detects a lot of patterns in between the database. Now, as I have this, why don't I create the ER diagrams and relationships? So usually the engineering team will sit and understands the data and have the diagrams ready. But in one shot, I have the ER diagrams. Just because the LLM understood what the relationship between the tables each and every, and it detects the foreign keys and it detects the primary keys. It was able to join all the tables that I have, which is accurate, that I can say, and it also detects the relationships. So let's say prescriptions tables and patients table. It says join these tables with the inner join for this particular use case. So it's giving me the additional information that I can implement on our databases, such that I can draw more information and draw more insights. This is how it's been. Now we'll come to the part where we'll check the quality of the data, and we'll also come to the part of ingestion. Now I'll generate the DBT rules, which is data build tool. I said it's a Python framework to test the quality of the data. Now while generating, it has the context of schema and whatever the relationships are, and it generates 3 things. The SQL, which is an actual code to apply on our dataset without we doing nothing much, and the YAML explains what and all it tests it's being doing, and the tests which are mapped to SQL and the YAML. So now I have the SQL which I can directly run. Now I have the YAML to understand what and all test has been happening, and now I have also everything ready. It's been generating, but it might take some time, but yes. So we have ER diagrams ready, we have joins and modelings ready, we have DBT rules ready. We'll also have the ingestion ready. Ingestion is nothing but ETL, right? So I did generate, I'll wait for its generation. I'll show data ingestion meanwhile. So what ingestion is? We have our databases in particular format. For example, I prefer SQLite database. They prefer Postgres or that format. They prefer DuckDB, which is anything. So they prefer something. Now ingestion comes where we can convert one database to another database. This can be done in 2 ways. One is ETL and another is ELT. ETL is where we use Python, which is a non-SQL language, to convert from one database format to other. What I'll do here is I'll select a source format, which is, for example, here is SQLite database, and I'll select a Parquet file, and I'll say generate. And if you have any concern, for example, I don't want PII information which are being tagged, for example, patient name. I don't want patient name row to be existed in the converted file. I can just say it and you can have it in the ready. So it generates the Python scripts to convert from one another, which are actually working. I tested every of them locally, so they'll work seamlessly. So we have schema ready, we have relationships ready, we have ER diagram ready, we have DBT rules ready, we have ingestion scripts ready. This reduces almost 80% of pipeline timing, or to build a pipeline for an engineering team to built in a month or so. So for every project, we build a context, we'll pass on what and all we need, we'll let LLM have us generate code. LLMs are very good at generating code but not guessing. So we'll leverage that advantage to generate the code to whatever we want and then use it in our pipelines, which will accelerate our work, which we can also finish faster. So this is what, and I believe by this time it should be generating the DBT rules. Yes, it is generated. So for example, for patient's table, and the test it's been doing is the patient ID. It's visible, right? Let me just zoom in. So the patient ID should be a unique identifier for each patient in the dataset, and it should not be null, it should not be unique, which are the constraints we see in the column descriptions. And it says patient ID greater than 0. And if you go to date of birth, it should be this particular regular expression, which is of 224 format or 422 format in this case, which is YY, MM and DD format. And yes, so it goes through every column, it creates tests for every column, which will help us to check the quality of the data. I mean, we have quality for every row, right? We have nullables in each row, we will be having nullables, we will be having some miscorrected information, so we can detect with it. And we can leverage the embeddings, which Sanchit said, by just creating a chatbot on top of it. So once we have all the information, we'll convert all these to embeddings and we can use a chatbot on top of it. For example, I'll ask it to add a new rule, it does add a new rule by understanding what the context has already been generated. So it's kind of human in the loop. We are using AI to, or in this case LLMs, to accelerate our process, accelerate our pipelines, and we have everything ready in 2 minutes. So that's how we can leverage, and this is only, I'm just presenting for an engineering use case, but you can use it for data scientist use case, where he will find the hidden patterns, he'll visualize the data or whatever it is. So the crux is we can use LLMs by providing the good context to have it whatever we can do, let it do. So it's not replacing the humans, we are the humans are using LLMs as a second brain, right? And we can accelerate things quite faster. I need to do this in 10 days, or I did it in 2 minutes. There will be human in the loops, there will be guardrails, and there will be a lot of things to check this, but we have the the initial scaffolding ready, so we can be fasten our processes for the next pipelines. So yes, that is pretty much from the live demo. I'll switch to the PPT. I should have it somewhere. Yes. So that's the data flow. We uploaded the data set, we retrieved the schema, we identified the information, and we created the visualizations and rules, whatever we want. And yeah, 0 to DBT rules in 2 minutes, and it detects the PII as well, because it has the information of what and all rows we have and what and all data types we have. And as I showed the chatbot, I haven't showed its working version, but it's a natural language to SQL chatbot, where we'll ask a question of generate a new rule, it does generate the SQL code for it. So we can run it everywhere, right? It's not a product page, but you can run it in the browser, you can run it in your backend, you can integrate with your CI/CD pipelines, and we can, everything is deterministic and reviewable here. So you can edit everything, and everything is visible to you. So it's a pretty good way of accelerating things that you actually do in the daily life. And by doing this, what actually stays the same? ETL is owned by Python, which we also traditionally use. So we can have the Python pipelines ready here. And DBT owns the execution. So for example, Schema Force generates the rules and DBT runs them. So if you download them locally, you install the Python package, pip install DBT, it will take care, and you will run the DBT rules that are being generated. So it's a tool that we will not think as a replacement of a human, because everyone is afraid of, okay, AI is taking my job, but it's not. So we are accelerating our job with AI. So it's kind of a second brain that we use. With that, I wanted to conclude, and yes, you can try, it's an open source, whole code base, it's there, and you can connect, and I can also be in an open source project. If anyone wanted a collaboration, you can scan the QR for GitHub and LinkedIn, all of them. and I'll take the questions now if any.